All right, so we have some given information both in the diagram and written across the top of the problem. First thing you can see is that it says triangle GIK is equilateral. What does it mean to be an equilateral triangle? Anybody got an idea? What's equal? Equal sides and
equal corners
and equal angle measures. Okay, so all the sides, you want to jot that down if you don't remember, all the sides and all the angles are equal measure. All right, now keep in mind the triangle they're referring to, and this is where you're really going to have to get good at identifying things, and I would highly recommend as you do these IXL problems to make a mock-up of the drawing with your dry erase markers on your desk, and then that way you can place markings in there, because that's what I'm going to do here, and that's what I would encourage you to do in your notes. But GIK is this triangle right here. This is triangle GIK, and they're saying the triangle GIK is an equilateral triangle. Okay, and if we know that, then that means that all three sides are equal to each other and all three angles are equal to each other, which, by the way, what's the degree measure of every angle inside of an equilateral triangle? Equilateral triangles, all three angles have to have the same measure, so they have to be what degree?
90.
Nope, 90 times 3 would be 270. What do all angles in a triangle have to add up to?
180.
180. So 180 broken into three parts is 60, right? So equilateral triangles always have 60-degree angles because all three angles have to be the same and they all have to add up to 180. Okay? Something that might be helpful for us to know. All right. So let's take a look at how the proof is built. Okay, the first piece of information that or the first two pieces of information really that they give us, that they have us put in here are the givens. The first one comes right from the statement. Okay, the second one comes from the markings. See the markings? So the second piece of information says angle HGI, this angle right here, HGI, is congruent to angle IKJ. So IKJ. And we know that because of the markings. So those two pieces of information are given. One's written, one's shown in the diagram, but they're both given. Okay, now, let's talk about what we need to prove. Here's the proof statement right here, and I'm going to use I'm going to use kind of a highlighter setup here. Let me use sort of a highlighter setup to kind of give you an idea of what we're trying to prove here. So we want to prove that triangle GHI, that's this triangle right here, is congruent to triangle KJI. KJI. All right, so we're trying to prove those two highlighted triangles are identical twins. In order to do that, we need to come up with three of those key pieces of information. Side, 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 angle, side, something like that. Now, as you look at those two triangles that I highlighted, you should already see, hey, look at that. I got one piece of information already. You already have one angle congruent between the two triangles. So there's really only two more pieces of information you need to find in order to be able to say, hey, these triangles are in fact identical twins. Well, let's see if we can find some of that information, okay? Now, this proof is already set up for you, so you don't have to do a whole lot of hunting and pecking for it, but they do tell you right here that angle JIK is congruent to GIH, so JIK, this angle right here, is congruent to GIH, this angle right here, and they give us the reason. Those are vertical angles, right? Vertical angles are always congruent. So if you're making these drawings on your whiteboards or, pencil or paper, whatever, we can mark in a couple of congruency marks here, because those are vertical angles. And now you can begin to see, look, now we got two angles already. And so we're probably going to lean towards either angle, angle, side, or angle, side, angle. It's not going to be side, side, side. We've got two angles. We don't have any side information. Probably going to be one of the angle ones. We're going to be looking for that. All right, now, check out this statement right here. IK is congruent to GI. That's segment IK, or side of a triangle IK. So I'm going to mark that in blue. IK is congruent to GI. Well, why can we say that? We can say that because of the equilateral triangle. If we wanted to, we could actually make a third mark right here. It doesn't really help us so much in the sense of proving our two triangles congruent, but I make it just so that you see where this information came from. It came from the fact that they told us initially this was an equilateral triangle, which means that all three sides need to be congruent. And since this side is congruent to this side, and both of those are part of our triangles we want to prove, you should be able to see now that we've got an angle, a side in between, and an angle. We've got an angle, a side in between, and an angle. So when you come down to your final statement, are those two triangles congruent? You would say, yeah, those triangles are congruent because of angle, side, angle. And so on your drop down, you would be looking for angle, side, angle.